Title: China's 800 million luxury tower is warping. 160-kilogram stone slabs are raining onto the metro station below. Music: heavy, thudding electronic beat with a sense of urgency. Narrator: Christmas Day, 5:15 p.m. In the heart of the Tianhe district, Guangzhou's glittering, hyper-dense financial core, the holiday rush is in full swing. Tens of thousands of commuters are pouring into the Linhexi metro station plaza, surrounded by towering walls of glass and polished steel. Sound effect: a loud, ripping tear. The sound of stones snapping under intense attention. Suddenly, a terrifying sound cuts through the traffic roar. High above the street, on the facade of the newly completed 83-story Huaxin Energy Tower, a massive 160-kilogram slab of premium white Italian marble rips free from its anchors. Sound effect: whistling wind. Followed by a deafening crash. The heavy stone panel plummets more than 300 meters through the air, gathering terminal velocity before smashing directly through the glass atrium roof of a luxury shopping mall next door. Shards of glass and pulverized marble explode across the concourse. It was an absolute miracle no one was killed. The Huaxin Energy Tower had been open for barely a year, standing a staggering 346 meters tall and clad in over 43,000 individual panels of imported, pristine white marble. This megastructure was built to project absolute permanence, wealth, and prestige onto the Guangzhou skyline. The chief architect, Wang Jiangwo, had famously boasted during the ribbon-cutting ceremony that this flawless white stone would make the tower an eternal monument, comparing its purity to classic imperial sculptures. That falling 160-kilogram slab should have been a catastrophic wake-up call for the municipal safety inspectors and the developer, Huaxin Real Estate Group. It should have triggered an immediate emergency halt to operations. Instead, the developers treated it as a completely isolated, one-off anomaly. They blamed a localized installation error, patched the roof next door, and kept the tower fully open. But gravity and material science do not care about corporate face-saving. Over the next 15 years, the decision to ignore that warning sign would transform this landmark luxury high-rise into a ticking time bomb. Nearly a third of those 43,000 premium marble panels would slowly bow, crack, warp, and threaten to rain down onto one of the busiest pedestrian zones in southern China. Music transition: dark, investigative Sabas, to understand how a premium, multi-million yuan megaproject could fail so fundamentally. We have to go back to the late 1990s and early 2000s, during the absolute peak of China's urban corporate skyscraper boom. Municipalities across the country were racing to build ever taller, ever bolder architectural monuments to showcase their economic dominance. In Guangzhou, Huaxin Energy Group wanted a headquarters that would announce exactly who they were to the world. They didn't want another generic, blue glass and steel curtain wall box like every other building in the district. They demanded an architectural monolith that radiated institutional solidity and unyielding power. They hired Wang Jiangwo, one of the most prominent, award-winning architects in the country, to realize this vision. In that hyper-competitive climate, Wang's pitch for something truly distinctive was an instant hit with corporate executives. Wang's vision centered entirely on the exterior skin of the tower. He insisted on using pure white Carrara marble, imported directly from the Apuan Alps in Italy. He argued that the natural stone would give the tower an unparalleled, timeless prestige that glass simply could not match. But there was a catch. Marble is incredibly heavy, and wrapping an 83-story skyscraper in solid stone is an engineering nightmare. To make the financial and structural case work to the board of directors, the design team shaved the thickness of the marble panels down to the absolute bare minimum, just 3 centimeters thick, cut into squares roughly 1.2 meters wide. On paper, the math looked brilliant. Thinner panels meant less raw material costs, lighter structural loads on the massive steel frame, and faster installation times. The developer believed they were getting international, imperial-grade prestige at a highly optimized, modern budget. What the computer models failed to account for was how a fragile, 3-centimeter thin slab of crystalline natural stone would actually perform at high altitude, subjected to violent seasonal typhoons, extreme thermal shifts, and the immense structural swaying of an 83-story megatower. This was an expensive engineering disaster in the making, and the countdown had already begun. Music transition. Rising synths with an accelerating heartbeat narrator to understand why the Huoxin Energy Tower was doomed from the moment its skin was bolted on. We have to look beneath the surface at the precise structural engineering of the high-rise. The tower utilized a cutting-edge tubular steel frame system designed by a premier engineering institute in Shanghai. It featured a massive reinforced concrete inner core tied to heavy perimeter steel columns by an intricate network of structural steel trusses. The building was engineered to flex. In a high-density, coastal megacity like Guangzhou, a 346-meter tower cannot be rigid. It must sway to survive the immense lateral wind loads pushed across the Pearl River Delta. The white marble facade was hung on the outside of this flexing skeleton like a rigid stone skin. Over 43,000 individual panels were suspended from the ground floor to the roofline, making it the tallest stone-clad skyscraper in Asia when the keys were handed over. From the bustling streets below, it looked like an unyielding white monolith. The fatal flaw was that nobody had rigorously tested how these ultra-thin, 3-centimeter slabs of metamorphic stone would react when subjected to the brutal, chaotic microclimates of southern China while bolted to a shifting steel frame. Sound effect. Wind howling mixed with the metallic creak of a tower swaying. Guangzhou's climate is notoriously punishing on building envelopes. In the summer, solar radiation beats down on the tower's south and west faces, driving surface temperatures up past 55 degrees Celsius. In the winter, sudden cold fronts drop temperatures down to single digits. Add to that the torrential downpours of the monsoon season and high-velocity typhoon winds, hammering the upper levels at altitude. The marble chosen for the facade consists almost entirely of pure, tightly packed calcite crystals. And calcite possesses a highly unusual, destructive property that material scientists call anisotropic thermal expansion. When a material exhibits anisotropic behavior, it means its physical properties change, depending on the direction of the force or temperature change running through it. In calcite crystals, they expand along one axis when heated, but actually contract along another axis at the exact same time. For thin marble panels on a massive skyscraper, this creates a catastrophic microscopic tug-of-war every single day. The sun intensely heats the outer face of a 1.2-meter panel, causing the calcite crystals on the surface to swell and shift. Meanwhile, the back face of the panel, tucked against the shaded structural insulation, remains cool and stable. The two sides of the exact same 3-centimeter thick stone slice are trying to move in completely opposite directions. In a traditional, thick masonry block used in low-rise construction, there is more than enough material mass to absorb, distribute, and damp these internal stresses without permanent structural damage. But in these cost-optimized, ultra-thin panels, there is no mass left to fight the stress. As the sun-facing side expands, it forces the entire panel to bow outward, curving like a sail away from the building's frame. When night falls and the temperature drops, the stone tries to snap back to its flat state. But because the microscopic crystal lattice has been fundamentally disrupted, it never returns to zero. It remains permanently, irreversibly warped. Engineers define this destructive cycle as thermal hysteresis. Sound effect, scanning tone echoing metal. Every single sunrise and sunset acts as a mechanical pump, slowly bending and weakening the stone. Across hundreds of intense heating and cooling cycles per year, the panels develop a permanent, creeping deformation. And this is where the engineers hired by Huoxin Real Estate Group made their most critical oversight. They believed the bowing was merely a cosmetic issue, an aesthetic blemish on an otherwise beautiful tower. They were dead wrong. Forensic investigations later revealed that every single millimeter a panel warped represented a massive loss in its internal structural capacity. The marble was shedding its tensile and flexural strength with each passing season. The stone skin was literally rotting from the inside out, and because it was happening hundreds of meters in the air, nobody was measuring the decay. By the early 2000s, the physical evidence of this material failure became impossible to ignore. On the south and west facades, which absorbed the most brutal daily solar radiation. Panels that were supposed to be completely flush with the structural grid were visibly bulging outward by 10, 20, and even 35 millimeters. From the ground, the tower's sharp, clean lines began to look strangely wavy and distorted. Hairline fractures rippled along the natural grain lines of the stone. Then came the minor failures that the developer tried to hush up. In 2003, a panel sheared completely in half along the 45th floor, sending 80 kilograms of stone crashing down into a restricted service alleyway. In 2005, another slab peeled away from its top anchors, dangling precariously over a major thoroughfare until fire rescue crews staged a midnight emergency intervention to strap it down. Despite these glaring warning signs, the building remained a premium, high-rent hub. Fortune 500 tech firms and massive domestic banks occupied the upper floors. The ground floor lobby remained a pristine palace of polished marble, while 1,000 feet above the heads of unsuspecting executives, thousands of tons of stone were actively tearing themselves away from their steel anchors. Music transition. Heavy, drifting dramatic synth narrator. The escalating crisis at the Huashan Energy Tower was not an isolated anomaly in the world of high-rise construction. It was part of a terrifying, repeating pattern across the landscape of rapid, modern megacity development. To understand the true scale of what engineering inspectors were dealing with in Guangzhou, you have to look at the broader context of architectural failures that have haunted other landmark towers across mainland China. Take, for instance, the infamous 2021 emergency at the Seg Plaza in Shenzhen. That 72-story skyscraper suddenly and violently began to shake, causing thousands of terrified people to flee through the streets of the Huaqiangbei Electronics District. For days, the public watched in shock as a modern tower, built to symbolize the country's tech dominance, stood completely sealed and empty. The culprit there wasn't a structural collapse of the concrete foundation, but rather a complex aerodynamic failure. Wind vortex shedding had synced perfectly with the natural resonant frequency of the building's massive roof mast and steel frame. It was a stark reminder to the entire construction industry: when you build at this extreme scale, minor miscalculations in physics can render an entire multi-billion yuan asset completely unusable in a matter of seconds. Sound effect. Distant thunder, rumble of city traffic. But while Shenzhen's crisis was driven by aerodynamics, Guangzhou's CRUMBLING was a fureur materials science, one that shared dark parallels with the glass curtain wall failures that have plagued high-rises from Shanghai to Chongqing. During the rapid construction booms of the late 1990s and mid-2000s, hundreds of luxury towers were wrapped in cheap or improperly treated tempered glass. Over time, microscopic inclusions of nickel sulfide inside the glass would slowly expand under the blistering heat of the Chinese summer. The result? Spontaneous explosions. Across major financial districts, multi-kilogram sheets of heavy tempered glass would suddenly shatter without warning, raining razor-sharp debris onto public sidewalks and crowded bus stops below. The Huashan Energy Tower was facing the exact same fundamental hazard, but on a far more massive, catastrophic scale. A shattered glass shard is dangerous. A 160-kilogram slab of warped stone falling from the 70th floor is an absolute weapon of mass destruction. By the mid-2000s, the local housing bureau and the Municipal Construction Commission could no longer turn a blind eye to the growing mountain of incident reports. The risk to public safety in the heart of Guangzhou was reaching a boiling point. The developer, Huashan Real Estate Group, was quietly ordered to bring in the China Academy of Building Research along with top-tier forensic engineering experts from Shanghai to conduct a full-scale, microscopic diagnostic assessment of the facade. What the forensic engineers discovered when they scaled the building sent shockwaves through the corporate boardroom. Sound effect. Digital metronome, ticking behind narration, using high-precision laser scanning and sonic testing equipment. The engineering team systematically mapped all 43,000 marble panels across the tower's 4 massive faces. The data was absolutely grim. Roughly 30% of the entire facade, more than 13,000 individual stone slabs, had already deflected outward by more than 15 millimeters. The worst-hit sections on the south and west exposures had bowed by a staggering 38 millimeters, creating massive, visible gaps between the stone and the moisture barrier backing. The team pulled dozens of compromised panels off the building's steel grid and brought them into a mobile laboratory for destructive load testing. The results confirmed their worst-case scenario. Thermal hysteresis had utterly destroyed the internal matrix of the Italian marble. The microscopic calcite crystals had ground against one another during thousands of solar heating cycles, creating a network of internal micro-fissures that couldn't be seen from the street. The tests revealed that the stone had already lost a staggering 40% of its original flexural and structural strength. Even worse, the engineers ran predictive computer models showing that if left in place, the marble would shed another 30% of its remaining strength within the decade. Then came the definitive blow: the high-altitude wind analysis. The Engineering Institute ran comprehensive wind tunnel simulations using an exact three-dimensional digital model of the Guangzhou skyline. They discovered that, due to the microclimatic canyon effects created by the surrounding newly built skyscrapers in the Tianhe district, the Huaqian Energy Tower was experiencing localized wind loads up to 20% higher than what the original municipal building codes from the late 1980s had ever anticipated. The final report laid out a terrifying mathematical reality. The marble was drastically weaker than designed, and the typhoon-level wind forces hitting it were significantly stronger than designed. There was absolutely no margin for error left. The stone skin was actively failing, and the forensic experts issued a blunt, uncompromising ultimatum to the owners: either strip the entire building to its bare steel frame, or prepare for a catastrophic, multi-panel failure that would rain thousands of tons of stone onto the streets of Guangzhou. Music transition, reverberating, low-freak industrial rumble narrator. By the late 2000s, the corporate boardrooms of Huaqian Real Estate Group were in a state of absolute, unadulterated panic. They were staring down a logistical and financial nightmare that had no precedent in the history of modern Chinese skyscraper construction. Their crown jewel asset, a 346-meter monument to corporate power located right in the center of Guangzhou's premium commercial zone, had just been declared a terminal public safety hazard. Every single day that passed without a solution was a multi-million yuan liability. If another marble slab broke free during rush hour and fell into the crowded plazas below, it wouldn't just be an engineering failure, it would be a corporate execution. But before committing to a full-scale, incredibly expensive total replacement, the owners desperately tried to buy themselves time. They needed a temporary fix to keep the tower operational, keep the high-paying corporate tenants from fleeing, and stop the stone from raining onto the streets.
Sound effect, metal drills, and pneumatic rivet.
Claiming their solution was a bizarre, visually jarring stopgap measure. The developer deployed fleets of industrial rope access technicians. Extreme high-rise window washers turned emergency construction workers to scale the 83-story facade. Dangling hundreds of meters above the Tianhe district, these workers systematically bolted thick, stainless steel straps right across the faces of the most compromised panels. The goal was simple: use external metal braces to physically clamp the warping marble against the structural steel frame, preventing the stone sails from peeling completely from their hidden anchors. The immediate result was an absolute PR disaster. The Huaqian Energy Tower, a building specifically designed by Wang Jiangwo to project smooth, unyielding imperial permanence, now looked like a skyscraper in traction. Thousands of highly visible metal straps wrapped the building's pristine white exterior, glinting awkwardly in the southern Chinese sun. Passers-by on the streets below didn't need an engineering degree to see that something was fundamentally wrong with the city's premier corporate address. Michelangelo's masterpieces had survived for centuries in European museums without needing external steel reinforcement. Guangzhou's ultimate luxury tower couldn't even survive 15 years on the Pearl River Delta before it had to be wrapped in structural bandages. Sound effect, police sirens blaring, pedestrian crowds shouting in confusion. While the steel straps held the major sections of stone together, they couldn't stop the micro-fissures from spreading inside the thin marble slabs. The perimeter sidewalks around the base of the tower became active hazard zones. The local municipal construction commission stepped in, mandating the construction of massive, reinforced steel and wood pedestrian crash tunnels over the walkways along the busy Linhexi metro station plaza. Security teams were deployed to constantly monitor the grounds. Specialized drone patrols flew up and down the south and west facades twice a day, using thermal imaging cameras to check if any of the thousands of strapped panels were developing new, sudden shifting patterns. Whenever high wind warnings or seasonal typhoon alerts were issued by the Guangdong Meteorological Bureau, authorities had to partially restrict public access to the surrounding plazas, routing thousands of angry, confused commuters away from the base of the tower. Inside the high-rise, the atmosphere was just as tense. Corporate executives like Li Wei, a senior risk analyst for a major domestic bank occupying the entire 62nd floor, recalled the eerie reality of working inside a failing megastructure every time a major seasonal storm walloped the coast. The immense lateral forces would cause the tower's flexible steel frame to sway back and forth. Inside the offices, employees could hear the horrifying sound of the exterior marble skin groaning, popping, and grinding against the steel anchors. It was a localized psychological war of attrition for the workers inside, knowing that just a few centimeters past their office window glass lay 6,000 tons of disintegrating stone skin held up by temporary metal straps. By 2009, the data from the monitoring drones and forensic sensors confirmed the inevitable. The stopgap measures were failing. The thermal hysteresis was progressing so aggressively that the marble panels were beginning to crush their own edges against the stainless steel straps, fracturing into smaller, unbraced fragments. The temporary solution had run its course. Total remediation was the only option left on the table. Sound effect. Heavy Industriemaschiner, Tonemergs. What followed between 2010 and 2013 remains one of the most complex, hazardous, and logistically insane engineering feats ever executed on a completed high-rise anywhere in the world. The developer had to pull off a full-body structural skin graft. They had to strip away all 43,000 failing marble panels and replace them entirely with a completely different material, all while the building remained 100% occupied and functional. Think about the sheer scale of that operational challenge. You cannot simply shut down an 83-story financial hub in the middle of Guangzhou without causing massive economic disruption. Thousands of white-collar workers continued to type at their desks, conduct international conference calls, and ride the high-speed elevators every single day, completely oblivious to the fact that just meters away from their chairs, heavy industrial demolition and reconstruction crews were peeling the walls off the building. The construction managers designed an immense, custom-engineered modular scaffolding system that crawled up the exterior of the tower like a mechanical parasite. At its peak, this temporary steel structure was one of the largest and highest scaffolding grids ever erected in Asia, featuring integrated heavy-duty debris containment netting designed to catch everything from an industrial bolt to a shattered block of stone. Sound effect rhythmic metallic, clanking of scaffolding climbing. The work had to be sequenced with absolute mathematical precision based on altitude, wind exposure, and seasonal weather patterns. Because removing the stone cladding exposed sections of the inner steel frame and vapor barriers to the elements, crews could only strip away small, highly controlled zones of marble at any given time. If a sudden, unpredicted typhoon caught the tower with its protective skin half peeled off, the internal wind pressures could tear through the building's interior infrastructure, blowing out floor-to-ceiling office windows from the inside out. For 3 grueling years, elite high-altitude construction crews worked in rotating shifts around the clock. The logistics of moving thousands of tons of heavy material up and down the exterior of a busy downtown skyscraper without disrupting city traffic required a flawless dance of heavy tower cranes and exterior material hoists. Operating primarily during the dead of night, piece by piece, row by row, the failing Italian stone was unbolted, crated, and lowered down to ground level, immediately replaced by massive 5-centimeter thick panels of Mount Airy white granite imported from pristine quarries in North Carolina. USA, the engineering team had completely abandoned the idea of cost-optimized thinness. They chose a highly dense, uniform, and weather-resistant American granite with interlocking mineral grains that do not expand anisotropically under thermal stress. The new granite skin was nearly twice as thick as the original marble and was mounted using a completely redesigned, heavy-duty three-dimensional aluminum anchor system engineered specifically to handle the highest calculated typhoon wind loads of the Pearl River Delta. When the final tally was calculated, the financial damage of this material, science blunder, was staggering. The original construction of the Uashin Energy Tower in the late 1990s had cost the developer roughly 800 million yens. The total cost to execute the 3-year granite recladding operation, including forensic engineering fees, scaffolding infrastructure, and public safety containment systems, ran between 450 million and 550 million yen. The developer did everything in their power to keep the exact financial figures from leaking to the domestic media, but the math was clear to every real estate analyst in the country. Fixing the facade had cost more than half the price of building the entire skyscraper from scratch. It was a monumental financial hit that wiped out over a decade of commercial leasing profits, a harsh lesson written in stone and steel that shook the Chinese high-rise development industry to its very core. Music transition. Solemn, reflective electronic pad with a slow, steady beat narrator. When the final panel of American granite was locked into place in late 2013, the building officially shed its old identity. Rebranded and structurally reborn, the tower still dominates the Guangzhou skyline today, now a completely stable, fully functional skyscraper wrapped in a robust, weather-resistant stone skin designed to last for generations. But the completion of the project left behind a bizarre, haunting question. What do you actually do with 43,000 failing panels of premium Italian Carrara marble once you strip them off an 83-story tower? We are talking about nearly 6,000 tons of high-grade, imported stone. This was the exact material that architect Wang Jiangwo promised would make the tower an eternal monument to corporate power. Instead, it had become half-ruined, structurally dead structural debris. The ultimate fate of that historic stone skin mirrors the hyper-pragmatic reality of China's industrial recycling capabilities. Sound effect. Heavy industrial crusher, grinding. 2/3 of the warped marble panels were loaded onto heavy flatbed trucks and hauled away from the shiny corporate center of Guangzhou, destined for an industrial fate. The stone was dumped into massive industrial crushers and pulverized into fine landscaping aggregate. From there, it was transported to a massive petrochemical refinery complex operating along the coast of the Pearl River Delta. 6,000 tons of Renaissance-grade Italian stone, imported at astronomical expense to build a corporate palace, ended up spread across the dirt grounds of an oil refinery as gravel, trampled under the boots of industrial workers in the shadow of smoking exhaust stacks. Another large batch, roughly 1/6 of the total volume, was donated to a regional university campus located in the outer suburbs of Guangdong Province. The warped, cracked slabs were stacked like discarded playing cards in a remote, forgotten corner of a campus parking lot. Over time, university groundskeepers repurposed the historic marble as riprap, piling the 3-centimeter slabs along the muddy shorelines of the campus retention ponds to protect the soil from eroding during the heavy monsoon season. The stone of Michelangelo's masterpieces, reduced to mud-soaked bank reinforcement at a suburban college, the final remnants of the facade met perhaps the most ironic fate of all. A small, state-subsidized manufacturing enterprise acquired several hundred intact panels. They utilized workers to saw the salvageable sections of the warped stone into small, polished corporate gifts and executive desk accessories. For years, the very executives who managed the building's fallout could purchase paperweights, pen holders, and bookends made from the exact facade that had threatened to crush them from 300 meters in the air. Music transition, rising. Cautionary finalathum. Ultimately, the saga of the Guangzhou Marble Tower became far more than just an expensive, embarrassing corporate footnote. It evolved into one of the most famous, definitive case studies in the history of modern structural engineering and material sciences across Asian universities. It serves as the ultimate textbook warning of thermal hysteresis in curtain wall design, and a brutal lesson in what happens when soaring architectural ambition completely outruns the fundamental laws of physics. The disaster forced a massive, industry-wide shift across China's construction sector. The catastrophic data gathered by the China Academy of Building Research during the crisis directly influenced major updates to national high-rise building codes and testing standards for natural stone cladding before this failure. Developers across rapidly expanding Tier 1 and Tier 2 cities routinely pushed the boundaries of material optimization to save on structural weight and costs. After Guangzhou, the entire industry learned that accelerated climate weathering tests, site-specific wind tunnel modeling, and strict material thickness guidelines are not luxury, optional extras. They are the thin, non-negotiable line between a landmark that ages gracefully and a public safety hazard that has to be stripped to its skeleton before its 20th birthday. The lesson left behind in the soil of Guangzhou is simple, brutal, and absolute. A microscopic miscalculation in stone thickness chosen entirely to balance a corporate spreadsheet and sell a grand poetic vision of permanence triggered a multi-year public safety crisis, wiped out $500 million in capital, and forced one of the most logistically hazardous engineering interventions in modern architectural history on the skylines of our modern megacities. Permanence cannot be faked, and physics never takes a day off.